So you're saying I can ask this cat any question?
The cat is connected to the computer. You just type in the question, it will read his mind. There the answer comes.
You're the man! I've been looking for this for weeks.
We want to find the inverse function for each of the given one-to-one functions. They're telling us the given functions are one-to-one so that we know that the inverses are also inverse functions. Remember, functions and inverse functions undo each other. So for example, if f of x equals y, then f inverse of y would be equal to x. So for every point on the function with an x-coordinate of x and a y-coordinate of y, the inverse function would contain a point with an x-coordinate of y and a y-coordinate of x. Notice how if we have a point on a function and we interchange the x and y coordinates, we would find a point on the inverse function. And we can use this idea to help us determine an inverse function given a function. The first step here is going to be to replace f of x with y. So we have y equals 3x minus 5. And then to determine the inverse function, we're going to interchange the x and y variables. So the inverse function would be x equals 3y minus 5. But now we do want to solve this for y and then replace y with inverse function notation. So to solve this for y, we'll start by adding 5 to both sides of the equation. So on the left we'd have x plus 5 equals, on the right this is 0, so we just have 3y, and we divide both sides by 3. So we have y equals the quantity x plus 5 divided by 3. This is our inverse function, so now we'll replace y with f inverse of x. So f inverse of x is equal to the quantity x plus 5 divided by 3. Or if we wanted to, we could write this as two separate fractions. We could write f inverse of x is equal to x over 3 plus 5 over 3. Written like this, we can see that the inverse function is just a line with a y-intercept of 5/3 and a slope of 1/3. And if we do have access to graphing software, there's a nice graphical way to verify that we have found this inverse correctly. If we graph the original function and the inverse function on the same coordinate plane, along with the line y equals x, the function and its inverse should be symmetrical across the line y equals x. So for example, in blue we have the graph of the original function, and in red we have the graph of the inverse function. And this thin black line is the line y equals x. Notice how if we were to fold these two functions across the line y equals x, they would match up perfectly with the other function, therefore they're symmetrical across the line y equals x, verifying we found the inverse function correctly. Let's take a look at our second example. Again, the first step is to replace f of x with y, so we have y equals 4x cubed plus 9. And now to determine the inverse function, we just interchange the x and y variables. So the inverse is going to be x equals 4y cubed plus 9. Again, this is the inverse, but we do want to solve this for y, so we'll start by subtracting 9 on both sides. So we'd have x minus 9 equals 4y cubed. Divide both sides by 4. So we have y cubed equals the quantity x minus 9 divided by 4. And now to undo this cube, we will cube root both sides of the equation. So on the right side we now have y. On the left side we'd have the cube root of the numerator all over the cube root of 4. But if we're required to rationalize the denominator, we'd want the denominator to be a perfect cube, and since 4 is equal to 2 times 2, If we multiply this by the cube root of 2, we'd have the cube root of 8, which would simplify perfectly. So we must do the same to the numerator. So now we have y equals, again the denominator is going to be the cube root of 8, which is 2, and then for the numerator we're going to have the cube root of 2x minus 18. And now we'll go ahead and replace y with f inverse. So f inverse of x is going to be equal to the cube root of 2x minus 18 divided by 2. And again, let's go ahead and verify this graphically by graphing both the given function and the inverse function on the same coordinate plane to see if they're symmetrical across the line y equals x. Looks like on this graph I switched the colors. The red function is the original function, and the blue function is the graph of the inverse function. But notice how they are symmetrical across the line y equals x, verifying that we did find the inverse function correctly. Okay, we'll take a look at 2 more examples in the next video.